Alright, so this is going to be a video about another integration by parts example problem, only this one was kind of tricky, so that's kind of why I wanted to spend a little bit of time going over it. So spoiler alert, you are going to have to use integration by parts to solve this, so rather than going through the normal process that I covered in the other videos, I'm just going to skip right ahead and say this is integration by parts. Let's get started on this problem. Okay, first thing we need is to figure out what our u is. Following that Lyate principle, if there's a log, then we want that to be our u. There isn't. Inverse trig, there isn't. Algebraic, there isn't one. Trig, there is one. It's that cosine 2x. So your cosine 2x is going to be your u. Your du is going to be equal to negative 2 sine of 2x using chain rule times dx. Your dv, since this is your u, your dv is going to be the e to the x dx, which means your v is e to the x. Now that we have everything for integration by parts, we can start filling in the formula. All right, I'm going to say this is equal to a, and that means that a is equal to uv, which is e to the x cosine 2x, minus the integral of e to the x, so it's v, times du, which is this right here, so times negative 2 sine 2x dx. Now you might be thinking, uh-oh, I just got into another e to the x times a trig integral, which is what we started with at the very top. That's kind of why I wanted to go over this, because again, we are going to have to use integration by parts to solve this, and it's still tricky after that, so make sure you're still on board the bus here as we're going. Okay, this one, our u is going to be, again, a trig expression. In this case, it's the negative 2 sine of 2x, which means our du is equal to negative 4 cosine 2x dx. This is just using chain rule. This should be a review of Calc 1. If you don't know how I got from u to du, then you might be a little bit behind, and you're going to want to review chain rule. Our dv is going to be equal to e to the x dx again, with our v being equal to e to the x. Now, you might see where we're going here already. If not, that's totally okay. This is going to start making sense shortly. Okay, so our a, which is what I defined the integral to be, is going to be equal to e to the x cosine 2x, that's just this part right here, minus uv, actually I'm going to put this in parentheses, uv, because we have to do integration by parts formula, minus the integral of e to the x times negative 4 cosine 2x dx. Holy cow, where do we even start on this? Well, if you have a keen eye, you'll notice something really interesting here. This part right here looks really similar to a. In fact, this part right here is actually equal to negative 4a, because it's the same thing as a, only there's a negative 4 constant multiple in there. So what I'm going to do is rewrite this entire expression to be a 4a there instead of that entire integral. So it's going to be a is equal to e to the x cosine 2x plus 2e to the x sine 2x. Yeah, that's embarrassing. I just noticed this should have been a 2x. Well, it's always good to check your work. Okay. And then I distributed this minus to the plus here. I also have to do it here as well. So it's just going to be plus, in this case, it's going to be equal to negative 4a. So I'm just going to put negative 4a in there. Here, I'm going to add the 4a to the other side, and now you have 5a is equal to e to the x cosine 2x plus 2 to the e to the x sine 2x. Okay, now the whole point of this entire problem was to solve for a. Okay, I have so many arrows pointing at a right now, but the whole thing was to solve for a. So now to solve for a, all we need to do is divide both sides by 5. You end up with the final answer of a being equal to e to the x cosine 2x plus 2e to the x sine 2x, and then all of this is divided by 5. Okay. Now, since this is an antiderivative, you will need a plus c. I didn't really leave enough room here for the plus c, so that's embarrassing. Give me a second. So I'm going to add in a little plus c right here, and you end up with your antiderivative right there, which is a very involved, very tricky, not intuitive way of solving for indefinite integral, because we had to utilize the fact that this negative 4a right here can be used in the equation to simplify. So it's basically you're substituting in an integral, which is, again, not intuitive at all, so it's a little tricky. So you might see a problem like that, and just be aware that this might be a technique that you're going to need to use. So that's another integration by parts example problem. If you have any questions about anything in this video, let me know.